In this section, we're going to look at solving equations involving polynomials. Now, this may look a little large and intimidating, but it comes out quite quickly. First thing we need to do is, like we were just doing, is distribute. So I'm going to have 12b. This may look a little intimidating, but it comes down pretty quickly. First thing we're going to do is distribute. So we'll have 12b plus b squared. The 7 doesn't have any parentheses, so we're just copying that one down the way it is. 2b, same thing. And we can distribute this b, so it'll be minus 4b plus b squared. Well, let's combine our likes on each side. Okay, the left side doesn't have any likes. Bummer. Oops, I lost my plus. On the right side, however, I've got 2b minus 4b, so negative 2b plus b squared. Now, if I subtract b squared from both sides of the equation, something magical happens. Oh, look, it went away. Now, my goal is to get the variable on one side by itself. So normally I'd like to add the 2b to both sides, but it'd leave me at 0 there. So I'm going to subtract 12b from both sides of the equation. So I'm getting b on one side, the constant on the other. So now I still have that negative 7 equals negative 2 minus 12 is negative 14, and there's our b. And if we divide both sides by negative 14, we get b equals negative by negative is a positive, and 7/14, I guess we should just reduce that. I was going to write a 7, don't do it. That's just going to be 1/2. I guess positive 1/2, that's nice. Now, it's always a good idea when solving equations to check. We're going to substitute back into the original equation, make sure it works. So where there was a b, I'm now putting 1/2, and then I have 12 plus b is now 1/2 minus 7, and I sure hope it is equal to, I'm just going to jog down here because I'm running out of room, 2 times 1/2 plus 1/2 times negative 4 plus 1/2. A lot of b's, a lot of 1/2s. Okay, simplifying the left side, 12.5 could be written as 25/2 minus 7, we hope equals, well, that's handy, 1/2 times 2 is 1 plus 1/2 times, okay, negative 4 plus 1/2 would be negative 3.5 or negative 7/2. And 1 times 25 is still 25. 2 times 2 is 4. Minus 7, I'm going to make that 28/4, giving myself a common denominator that I'm going to want in a second. And 1 times 7, ooh, it's negative 7. 2 times 2 is 4. So on the left side, 25 minus 28, they're all fourths, is negative 3/4. And on the right, if we change that 1 into 4/4 would be nice. So 4 plus negative 7 is also negative 3/4. My check step is happy. And you could have done that on a calculator, it'd be a lot faster, but I wanted to see how it works. Again, we're going to start off by using our distributive property. So x times x is x squared plus 2 times x, we'd write 2x. Then plus 2x times x is x squared. Positive times negative is a negative, so negative 6x. Plus 7 is just going to be what it is. Then on the right side, 3x times x is 3x squared. Minus 15x minus 12. When we combine our like terms, x squared and 2x are like terms, so 1 plus 2 is going to be 3x squared. And then 2x minus 6x is going to be minus 4x. And then we've got the 7 doesn't have any like terms, so he just stays plus 7. On the right-hand side, we have no like terms. All right, so we have 3x squared minus 15x minus 12 just is what it is. Okay, I want to get everything on one side, the x on one side, constant on the other. So first I want to subtract 3x squared from both sides of the equation. Goodbye. Okay, that wasn't very exciting. Let's copy down what we have left. We have negative 4x plus 7, negative 15x minus 12. So I want to get x on one side. I'm going to add 15x to both sides of the equation. And I'm lining up my like terms as I add. It's kind of handy. Negative 4 plus 15 is 11. Copying down that plus 7 yet again. The x's are gone, so I just have a minus 12. Subtract 7 from both sides of the equation. And the 7's are gone, so I've got 11x equals negative 19. Okay, so this one came out not very even. X equals negative 19/11. Okay, I'm not going to write out the whole check step on this one because it's going to be a lot of work arithmetically, and it'd be pretty handy to do on your calculator. So every place there's an x, you could put negative 19/11 in your calculator, and hopefully you get the same thing on both sides. So the big idea from lesson 8.6, the distributive property can be used to multiply a polynomial by a monomial. And then we can solve equations involving such things.